Okay, so now we're going on to E2, second part of this part of the exam paper, and this question is about the density of the universe. And then this says define critical density. Now, the critical density is a density in which the universe will just continue to expand forever, but there will be a slowing down. It continues to slow down, but it actually never stops. It will stop at an infinite amount of time. So different ways of saying that. Density at which the universe will forever expand, but the rate of expansion will approach to zero. This is in the Mark scheme. I'm sure you can get that no problem. Explain how the future of the universe will be predicted by comparing the estimated density of the universe to the critical density. Well, basically what happens is that if the density is high enough, so if your density of the universe is greater than the critical density, gravity, the force of gravity is going to be able to stop the expansion. So this is gravity. It will be able to stop it, slow it down, stop it, and it will start contracting. So the universe will then contract. If the density of the universe is equal to the critical density, as we have stated before, then what will happen is that it will just continue to expand but slowing down. So it will just continue with that. It will just expand but slow down. And if the density is less, if the density is less than the critical density, it will just continue to expand. Alright, so the future of the universe depends upon this, whether the universe is going to continue to expand or whether it's going to contract. And then for C, explain why the existence of dark matter makes it difficult to measure the density of the universe. It's difficult for us to see it because dark matter does not radiate any energy, or it doesn't radiate significant amounts of energy, and therefore it's difficult to measure, so it cannot be measured. There are ways of measuring. It's difficult to measure, but it's cannot be measured by radiated energy, which is the way that we measure most stars and so forth. We actually look at them. We can tell a lot about from that radiated energy. How they measure this is looking at the gravitational effects, because it's got mass. It exerts a gravitational effect, and so they can estimate the amount of dark matter by means of that. So that basically sums that question. Okay, thank you very much.